Now note there are two different types of forms when we're talking about two variables with linear equations. Both of them have an x and a y. Those will be our two variables. First is called standard form, where we have some constant in front of our x plus some constant from our y equals some constant c. So you can see here with this form, both of our variables are on one side of the equal sign. Then we have slope-intercept form, where now our equation is y equals some constant from x plus some constant. Notice that our equation here is a y equals. This will be the form we'll concentrate more on this class, because also this will be the form that's required in order for you to plug it into your calculator. Now, one of the things that you'll want to do is to change from standard form into slope-intercept form. One of the reasons why you want to do this is because a calculator cannot understand standard form. In order to plug it into it like a graphic calculator like the TI-83 or whatever, you'll have to put it into slope-intercept form. You're looking for something that has a y equals. So what we need to do is to solve for y in our standard form, which means I need to move my x over. I need to isolate my y. So the opposite of a plus 3x is a minus 3x on both sides. That'll cancel. Negative 2y equals 6 minus 3x. And last but not least, I need to get rid of this negative 2 being multiplied to my y. Opposite of multiplying by 2 is divided by 2. I need to do that to both my constant and my x value. Now I do get my y equals, and I'll go ahead and move this, the x in front. So 2 negatives makes a positive 3 over 2 x, and 6 divided by negative 2 is a negative 3. So this is how we're going to convert between standard form and slope-intercept form. And again, you'll want to do this because now I can plug this into my calculator. Hit the y equals button, type in 3 over 2x minus 3, and then hit graph. Can't do that with standard form. Now the reason why this is called slope-intercept form is because it has both the slope, in this case 3 over 2, and the y-intercept inside of itself. You can read those directly from this form. So my slope is 3/2 and my y-intercept is 0 because that's the value of x at our y value of negative 3. So my y-intercept is 0, negative 3. Let me take a detour and mention one of the best websites for graphing, and that is Desmos.com. DESMOS.com. As you see, you can graph any type of equation, either in standard form, slope-intercept form. You can also put in function notation, and you can put in multiple equations at the same time, so you can see the intersecting point. It'll automatically identify intercepts, and I do have an activity posted onto this chapter that you can check out. That will help with identifying slopes and how they change based on what values you have for the constant. So definitely Desmos.com is something you want to look at. A few things with slope. Notice we have a positive slope. It's slanting towards the right. A negative slope slants towards the left. Then there is a zero slope. You can almost think of if you're skiing on this slope, where are you going? You're going 0. You're not going anywhere. You're not moving. So that is a zero slope. It's going to look like something when you have a y equals a number, like y equals 3 or y equals 4. Also, a no slope, or also called the undefined slope, is when, picture you're skiing on this type of slope. You're pretty much going to die. So this is a undefined slope where you have an x equals a constant number, like x equals 3, x equals 4. Now, say you were given 2 points on a line and you want to find what is the slope of that line. You're going to use this slope formula here. Note that m represents slope. Don't ask me why they call it m. It's probably something German. And here's our formula. I want to take my y2 subtracted from y1 and my x2 subtracted from x1. Now note, it doesn't matter which one you call x1 and x2. It'll work out the exact same. Just make sure you stay constant that I'm going to go ahead and call this my 1 and this my 2. So my first value here is my x1. This one is my y1. This will become my x2, and this one will become my y2. And now I simply want to just plug these numbers right into this formula here, which will be given this formula on the test if you have to use it. So y2, which is negative 8, minus 3, all over x2, which is 1, minus negative 2. And again, 2 minuses makes a positive. So what does this equal? Negative 8 minus 3 is negative 11. All over 1 plus 2 is 3. So my slope is negative 11 thirds. Now, usually you would simplify this, but this can't be simplified any further. So my slope will be a negative 11 over 3. That will be a slope with these points on that line.